Okay, so let's answer this question. We need to find the critical points. We need to find where the function is increasing or decreasing. And then we need to find the extrema, and we need to say if it's a maximum or minimum, and don't forget to write that in an ordered pair form. To do this, we're going to use the first derivative test. To be able to use the first derivative test, we have to take the first derivative. The derivative of h of x, so h prime of x. We use the power rule and we get 3x squared minus 27. We have to use find our critical numbers. So we set this equal to 0. There's nowhere where this can be undefined. There's no dividing by 0. There's nothing crazy happening. So we set this equal to 0. We get 3x squared minus 27. Add the 27. We have 3x squared equals 27. Divide by 3. X squared equals 9. When you take the square root, do not forget the positive and negative. So we have two critical numbers. We have -3 and +3. Don't forget that you have a negative and positive when you take the square root. Okay? From there, we are going to use our first derivative test. Our first derivative test uses these critical numbers. We put our critical numbers on the number line in order, so we have -3 here, we have a +3 here. We need to pick some numbers to test in our first derivative test. We need to pick numbers in each section in between and on the outside of our critical numbers. So on this side of -3, I'm going to choose -4. And be careful when you're writing this on your paper because you're using a pencil. So one, you don't have different colors. Two, it's really easy if you write all of your numbers on the bottom right next to each other. It's easy to get those critical numbers and the numbers you're choosing to test mixed up. We need to keep them separate. So I write my critical numbers on the bottom, and the numbers that I'm using to test, I write on the top and circle them so that I can differentiate between them so that I don't use them in the wrong way. In between -3 and 3, I'm going to use 0, and bigger than 3, I'm going to use 4. Now, the first derivative test involves plugging these test numbers into the first derivative. So, I go back. -4, we have 3 times -4 squared minus 27. We will end up with a positive number. We plug in 0, we have 0 minus 27. We get a negative. And when we plug in 4, again, we get a positive because we're squaring, and then we'll have a larger number minus 27. So we can get a lot of information from this. Our derivative is positive, so our original function is increasing. Our derivative is negative in between -3 and 3, so our original function is decreasing. And our derivative is positive for any number greater than 3, so our original function is increasing. From here, we can get those increasing and decreasing intervals. Increasing, our function is increasing from -infinity up to -3. -3 is included in our domain. We have graph happening at -3, so that is included with a bracket. Our graph is also increasing 3 to infinity. And decreasing, we have one interval here. CRE, oh my goodness, I cannot spell. Let's try that again. Decreasing only from -3 to 3. So we have our critical numbers, we have our intervals of increasing and decreasing, and our first derivative test tells us that if we go from increasing to decreasing, that is where we have a maximum. And if we go from decreasing to increasing, that is where we have a minimum. So we just have to identify these ordered pairs, and then we'll be done. We know our x values. To find our y values, we plug into the original equation. So let's scroll back up. We have -3 and 3. When we plug in -3, you will get a positive 54. when you plug in, let's see, when we plug in positive 3, we get a negative 54. So let's scroll back down. Enter these in our ordered pairs. We have 54 here. We have negative 54 here. There are ordered pairs for our maximum and minimum, and we have answered every part of this question.